Hello everyone, this is K. Vaishnavi. I am graduating in Srinivasa Ramanujan Institute of Technology, second BTech first semester. Today my topic is environmental impacts of nuclear accident. Subject name is environmental science. Subject code is 23 NCM C01, holding roll number 244G1805AR. The Introduction to nuclear accidents and ecological concerns. Nuclear accidents can cause severe environmental contamination and long-term ecological damage. The Tokaimura criticality accident in 1999 serves as a significant case study. Understanding its ecological impacts helps improve safety measures and environmental protection strategies. And the next one, overview of the Tokaimura criticality accident. The accident occurred at a uranium processing facility in Tokaimura, Japan on September 30, 1999. It was caused by improper handling of uranium, leading to a critical nuclear chain reaction. The incident resulted in the release of radiation and exposure to workers and nearby residents, and the intermediate environmental effects of the accident. Radiation released into the environment contaminated the surrounding air, soil, and water sources. Local Local flora and fauna experienced acute radiation exposure, affecting their health and survival. The prompted evacuation restricted access to the contaminated area to prevent further ecological damage, and the radiological contamination of soil and water. Radioactive isotopes such as cesium-137 and iodine-131 were released into the environment. Contaminated soil pose long-term risks to plant life and soil organisms. Radioactive water runoff affected local waterways, impacting aquatic ecosystems. Impact of local flora and fauna. Radiation exposure led to genetic mutations and reproductive issues in local wildlife. Some species experienced population declines due to habitat contamination. Vegetation near the site signs of psychological stress and growth abnormalities. Long-term ecological consequences. Persistent radioactive contamination may remain for decades, influencing ecological recovery. Biodiversity could be reduced due to radiation-induced mortality and reproductive challenges. Ecosystem functions such as nutrient cycling might be disturbed by radiation effects. Human and ecological risk assessment. Risk assessments indicated potential hazards to both human health and the environment. Contaminated sites are required extensive remediation to prevent ecological and public health hazards. Ongoing monitoring is essential to evaluate the long-term ecological impacts of the accident. Remediation and the environmental recovery efforts. Soil decontamination techniques such as excavation and removal were employed to reduce radiation levels. Water treatment and containment measures helped prevent further aquatic contamination. Ecological restoration involved habitat rehabilitation and monitoring of flora and fauna recovery. Preventative measures. The Tokaimura accident underscored the need for strict safety protocols and staff training. Enhanced environmental monitoring systems were implemented to detect early signs of contamination. International cooperation and regulatory oversight are crucial to prevent similar ecological disasters. Conclusion. The Tokaimura criticality accident highlights the profound ecological consequences of nuclear mishaps. Ongoing research and improved safety standards are vital to mitigate future environmental impacts. Protecting ecosystems requires a combined efforts of technological, regulatory, and community-based approaches and the sustainable development. Thank you.